Hello, we'll be talking about organic chemistry. We'll be starting from the basics pertaining to the class 11th. So let's begin. A brief introduction about organic chemistry. The first organic compound, which was prepared from inorganic compounds which or synthesized, was urea. It was synthesized from ammonium cyanate, the formula being NH4CNO. It was prepared by a scientist named Wöhler. Okay, what he did was he at a very high temperature, NH4CNO or ammonium cyanate was converted to urea, NH2CO, NH2. This the thing which can be remembered from this equation. The chemical formula of urea, the one NH2 group will be coming directly from ammonia, once the CO coming from carbon dioxide, and one NH2 from aspartate. So these things can be remembered from the formula of urea. Next thing which we'll be talking about is a general formula or a concept which can be remembered so that it will be easy for you to get to know about the configuration and the bonds of a carbon in a carbon chain. To easily get to know about the bonds, the configuration, the shape, and the bond angle of a carbon in a carbon chain, you can use this table. See, if a carbon is bonded or everywhere by it has all four single bonds, it will be having 0 pi bonds. It is understood. Okay, then the configuration will be sp3, shape being tetrahedral, and the bond angle being 109 degrees 28 minutes. Similarly, if a carbon has two single bonds and one double bond, then it will be having 1 pi bond, the configuration being sp2, shape being trigonal planar, and the angle 120 degrees. Similarly, if it has a triple bond and a single bond, then 2 pi bonds, sp configuration, and planar shape, bond angle being 180 degrees. Now let us take an example. Triple bond. Now if I to ask you about the number of sigma bonds, number of pi bonds, the how many carbons have sp3 configuration, how many have sp2, and how many have sp, by using this table, by using this above table, you can easily get to know about this one. So starting from how many sigma bonds are there. Okay, so by counting here, the carbon is bonded to hydrogen by a single bond, so 1 sigma, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So total number of sigma bonds is 14. If someone asks you about how many pi bonds are there, so that will be 1, 2, 3, and 4. Only 4 pi bonds are there. How many sp3 carbons are there? As is said in the above table, if a carbon is bonded is having only single bonds, then it will be a sp3. So in the above carbon chain, you will be seeing two such carbons, sp3. Which are those carbons? If we see, this is one and this is the second one. These two carbons don't have a double or a triple bond. Similarly, if we get to know, if someone asks about the sp2 carbon, then there are two in number and sp is 3. The three are being 1, 2 and this one 3, third one over here. Okay, so here, how can this be a sp? If you ask, this can similarly be written as this. Okay, another example for the same problem, we'll be taking the example of a famous molecule, benzene. Okay, this is called the resonating structure of benzene. If it is represented like this, now tell me how many pi bonds, how many sigma bonds, how many sp2 and how many sp or sp3 carbons are there. By looking at the molecule, one can easily tell that all 6 carbons have configuration of sp2. How? As every carbon has a double bond. Okay, now if we ask how many pi bonds are there, the number of pi bonds here are 3 and the number of sigma bonds will be 12. How 12? If we expand the structure, H, add H to every carbon, you will be seeing that 1 2 3 4 5 1 2 3 4 5 6 1 7 8 9 10 11 and 12. So there are 12 sigma bonds. Generally, when you write the structure like this, generally everyone will be forgetting the hydrogens attached. So number of sigma bonds, sometimes by mistake it will be written as 6. That is a wrong thing. Now the next thing which people often get confused is the bond line formula. You have to always remember that in a bond line formula, which can be represented like this. For an example, every corner, every nook and the end points represent a carbon. So if I represent in a normal form, this will be so 1 1 2 2 3 3 4 4 5 5 6 6 7 7 8 8 9 and 9. So this represents that. So every time remember, every end point and nook or corners will represent a carbon. Be cleared is what is a primary, secondary, tertiary and quaternary carbon. So it is represented by this, this and this. So primary carbon or a first degree carbon is a carbon bound to single carbon atom, directly attached to single carbon atom. If a carbon is attached to here other groups can be there. 2 carbon atoms, it is called secondary. If it is attached to 3 carbon atoms directly, it is called secondary carbon atom, and a quaternary carbon atom is a carbon with 4 carbons attached directly to it. Now this quaternary carbon is important in the upcoming things. Next thing which is important and questions arrive is the IUPAC nomenclature. For this IUPAC nomenclature, very important formula which if kept in mind will be very helpful is in any carbon chain this formula is applicable. So to name any of the carbon chain, simply keep this in mind. You will be having the root word in the center. And now what represents a root word? It is the number of carbon atoms. It's the root word. It's a root word, the main word. It can be if 1 carbon it's present methane, if 2 carbons ethane, 3 carbons propane, and so on. After this root word, you'll be having a primary suffix and a secondary suffix. Here, a primary prefix and a secondary prefix. Okay. If this is kept in mind, you can name any of the carbon chain given. May it be of any length. Okay. So let me tell you what this primary suffix signifies. This primary suffix can be ane if a single bond, ane, ene if it's a double bond, and ine if it's a triple bond. A secondary suffix all of a functional group, alcohol, all for alcohol, aldehyde, al, ketone, ONA, and oic acid for carboxylic acid, COOH. Let me tell you about the primary prefix. It can be generally cyclo, or generally most of the time it's cyclo, and the secondary prefix, the substituents, which will be attached to the carbon chain. Now, after getting to know about the general formula for nomenclature, let's get to know about the rules for nomenclature, and this is for saturated compounds. The first rule is we should always select the longest carbon chain if it may it be straight or not. So keep in mind, always select the longest carbon chain. May it be straight, straight or not. For an example, C. So this is a straight chain, but also it is a longer one. 1, 2, 3, 4, 5. Okay, so we'll be selecting in this condition the straight one. But if this happens for the same this one, if this happens, still there is no difference in this one, so you may select this one or this one, all is same. Now if this happens, still. Now the second rule being the numbers to the carbon atom of the main chain can be given from a right or left, but the priority should be given to the substituent. Okay, here substituent is important. If substituent is attached, that substituent to which that carbon to which the substituent is attached should get the lowest number. So for example, so let us write it once. The carbon to which substituent is attached should be given the lowest number. So for example, let us take now we want to number this carbon chain. It can be numbered 1, 2, 3, 4, 5, 6. First rule, we should also obey the first rule over here. As the rules, I'm stating the rules, the previous rules should be followed. So first we want to follow the first rule. So this is the longest carbon chain. This is not the longest carbon chain, not this is. So we know this is the longest carbon chain, but we need to number it. We numbered it once from left side. Now we'll number it from the right to left. 1, 2, 3, 4, 5 and 6. According to the rule number 2, we have followed rule number 1. Now we are following rule number 2. That is, the substituent attached carbon should be getting the least or the lowest number in after numbering. So this one is the correct, as it's getting third number, whereas when you number it from left to right, it was getting a 4. Now while discussing the third point, let us recall the second point. It was said that the carbon to which the substituent is attached will be getting the lowest number. Now if more than one substituent is attached, so this rule is for that carbon chain in which more than one substituent is attached. So if more than one substituent is attached, we should number the carbon chain such that the substituent attached carbon, when added, the position numbers, if it is added, will be getting the lowest sum. So let me show it an example. See. So let's number this from left to right and right to left. Here is a substituent attached carbon. Here is substituent attached carbon. So 5 plus 3 we get a 8 and 4 plus 2 we get a 6. So the second one is the right. Let's talk about the fifth rule. The fifth rule says that if two substituents are present, I'm talking about substituents, not about the functional group as substituents. I'm talking about the normal one, methyl, ethyl or butyl, propyl and so on. Then while naming, the prefix should be presented in an alphabetical order. For example, if I take this one only from the third one. Third rule. This is just a continuation of third rule, okay? We first will number the longest carbon chain. 1, 2, 3, 4, 5, 6. Is this right? Yes, because lowest locant, lowest sum rule we have used. Now for naming this is a ethyl group and this is a methyl group. Ethyl group starting with E and starting with M. So the name as per the fifth rule will be 4-ethyl 2-methyl hexane. Now let's talk about the nomenclature for unsaturated compounds. So the rules which will be following will be almost similar to those which were followed for saturated compounds. The first rule being select the longest carbon chain with maximum number of multiple bonds. Even though the only difference is, even though it is not the longest one, it should have a double bond or a triple bond. So select longest carbon chain with maximum number of multiple bonds. As an example, if you see this, this is the longest carbon chain, but you will be selecting this one as per rule number 1. The second rule which will be following is the carbon atoms should be numbered right to left or left to right, so that the carbon having the multiple bonds or double or triple bond whatever should get the lowest locant. So the carbon with multiple bonds should be designated with a position with lowest number or locant, whatever. The third rule which will be following is, if more than one multiple bond is present, then as we had used previously in the saturated one, the lowest sum rule should be followed. More than one multiple bond present, lowest sum of the locant should be preferred. This is similar to that in the saturated one. Now in the multiple bonds as well, if there is a confusion, if the carbon chain has both double and triple bond, you will number it as though the sum will be minimum, but here the double bond should be given preference. An example for this one, directly an example. So when we number it from left to right, The sum of this one will be 6. When we number it from right to left, the numbering will be 1 plus 4, 1 plus 3. 1 plus 3, it will be a 4. Here we are getting the lowest sum for carbon chain when we have numbered it from right to left, but we'll be numbering it from left to right, though we are not obeying the third rule of lowest sum rule, because we'll be giving preference to the double bond than triple bond. So the exact numbering will be left to right in this case. Now, nomenclature with carbon chain having functional groups. The rules for this thing is, the first rule being, we'll be selecting the longest continuous carbon chain with functional group attached, even if it is not the longest carbon chain. As we told for the unsaturated compounds, to select the carbon chain with maximum number of multiple bonds, similarly here we'll be selecting the longest continuous carbon chain with maximum number of functional groups attached. So the first rule being, maximum number of functional groups attached, that carbon chain is considered to be the longest one. The second rule which we'll be following here is, the carbon atoms should be numbered as though the functional group will be the lowest locant, or the functional group, the carbon to which the functional group is attached, gets the lowest number. So give numbers to the carbon atoms so that the carbon atom to which the functional group is attached gets the lowest number. The third rule which we'll be following is, some functional groups, some functional groups, I'll tell you which functional groups, are chain terminating. That is, however you number the carbon chain, the carbon to which these chain terminating functional groups are attached, it should be having number 1, or the carbon chain should start from here. So I'll tell you which functional groups those are: COH, carboxylic acid, CHO, CONH2 amide, CN. These are also called the chain terminating functional groups. So if these are present in carbon chain, then the carbon to which these are attached will be numbered as 1, or simply, carbon chain starts from the carbon to which these chain terminating functional groups are attached. The priority order for the functional groups will be COH greater than SO3H greater than acid anhydride greater than ester greater than acyl chloride greater than amide greater than cyanide greater than aldehyde which is greater than isocyanide which is greater than keto greater than alcohol greater than thiol greater than amine, and the least one will be ether. There's a table regarding this one in your NCERT book. Please follow that one. In the next video, we'll be talking about isomerism. Thank you.